Hello good day viewers. In this tutorial I'm going to show you how you can solve this Olympiad mathematics question without any substitution. So we ask to solve the equation 4 plus root 15 to the power of x plus 4 minus root 15 to the power of x equal to 62. And we are only looking for the real value or values of x that can satisfy this equation. Alright, let's get started. First of all, you should know that 4 minus root 15 is just a reciprocal of 4 plus root 15. And how can you determine that? If you square 4, you're going to get 16. If you square root 15, you're going to get 15. And therefore, 16 minus 15 is equal to 1. So whenever you have this situation, then the two terms are said to be reciprocal of each other. All right. So we have 4 plus root 15 to the power of x plus, instead of this, we can write it as 4 plus root 15, but we have to negate the exponent because they are reciprocal of each other, remember. So we have 4 plus root 15 to the negative x, and this remains 62, sorry. All right. Now I would like to multiply all these 3 times by 4 plus root 15 to the power of x. So let me start from the first one. We have 4 plus root 15 to the power of x multiplied by another 4 plus root 15 to the power of x. We move to the second term. 4 plus root 15 to the negative x multiplied by 4 plus root 15 to the power of x. This is equal to 62 multiplied by 4 plus root 15 to the power of x. So we have just multiplied all the 3 times by 4 plus root 15 to the power of x. According to one of the laws of indices, you can see here we have common bases, and hence we can add the exponents and take a single base. So this becomes 4 plus root 15 to the power of what? 2x, because x plus x is 2x. Then plus, can you see that we have common bases? Therefore, we can add the exponents. And once you add the exponents, you're going to get 0. So this becomes 4 plus root 15 to the power of 0. We can even bring this one inside. We have minus 62 multiplied by 4 plus root 15 to the power of x. And to the other side, we have 0. According to one of the laws of indices, we can rewrite this one as 4 plus root 15 to the power of x, but whole to the power of 2. And this is 1 because any number to the power of 0 is 1 except if the number is 0, right? So this is 1, but I would like to write this one before the 1. So we have minus 62 multiplied by 4 plus root 15 to the power of x, then plus 1. This is equal to 0. This is now a quadratic equation in terms of 4 plus root 15 to the power of x. And the leading coefficient here is 1. Therefore, a is equal to 1. The coefficient of the middle term, b, is equal to negative 62. And the constant c is equal to 1. Remember our formula is always equal to minus b plus or minus into square root of b squared minus 4ac divided by 2a. So now let us plug everything, but this is what we are solving for, the whole of 4 plus root 15 to the power of x. So we have 4 plus root 15 to the power of x equal to minus b, but b is already negative, so once you negate it, it becomes positive. 62 plus or minus into square root of b squared, b is negative 62 whole squared, then minus 4 multiplied by a is 1, c is also 1. divide by 2 multiplied by a is 1. Okay, let me simplify the right hand side. This is equal to 62 plus or minus negative 62 to the power of 2 will give us what? 3844 minus 4 times 1 times 1 is 4, divided by 2 times 1 is 2. This is equal to 62 plus or minus into square root of 3844 minus 4 will give us 3840 divided by 2. This is equal to 62 plus or minus into square root of 3840 is the same thing as 256 multiplied by 15 divided by 2. If you want to do this, because we are dealing with sort, you have to think of the biggest perfect squared factor of 3840, which is 256. Then the square root of 256 is 16. So this is equal to 62 plus or minus 16 outside. Then inside we have 15. Divide by 2. If you divide this 2 times by 2, you have 31 plus or minus 8 square root of 15. Remember what we have to the left hand side is what? 4 plus root 15 to the power of x. So since we have plus or minus here, let us split them into 2. So 4 plus square root of 15 to the power of x is either equal to 31 plus 8 root 15, or 4 plus root 15 to the power of x is equal to 31 minus 8 root of 15. So we have two equations, 1 and 2. Let's start with the first one. So from the first one, we have 4 plus root 15 to the power of x equal to 31 plus 8 root 15. So this is 4 plus root 15 to the power of x equal to 31 plus 8 root 15 is the same thing as 4 plus root 15 to the power of 2. Once we expand this, you're going to get this back. And since we have common bases, we can equate the exponents, and hence x must be equal to 2. This is one of the solutions. Then let us pick the second equation, which is right here. So here is the second equation. 4 plus root 15 to the power of x is now equal to 4 minus root 15 to the power of 2. Once we expand this, you're going to get this back. But the bases are not the same. But remember, I told you that they are reciprocal of each other. So we can write this as 4 plus root 15 raised to the power of x equal to 4 plus root 15 to the power of negative 2, because you have to raise this to the negative 1 for it to be the reciprocal of this. And that negative 1 will have to multiply 2. So now the bases are the same, which implies that the exponents are also the same. So we have two values of x that can satisfy this equation, which are x equal to 2 or x equals negative 2. This is the solution to this problem. But if you like, you can test them in the main equation. Just plug them here. Replace this with 2. Simplify the whole of the left hand side and see whether you're going to get 62. Then you replace x with negative 2 again. Simplify and see whether you're going to get this. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.